Hello, we are going to simplify, solve, add, and subtract rational equations. So I'm just going to get started with these, which is simplify each one of these rational expressions, and then we're going to state restrictions on a variable. So the first thing that I'm going to want to do in each of these is factor. So in this top one, I can take out a 4, and if I divide each of these terms by 4, I get x plus 5, and on my denominator, I'm going to take out a 3. And if I do that, I'm also left with x plus 5. So at this point, what you want to do before you cancel off these x plus 5s is you want to take this denominator one and set it equal to 0. So if x plus 5 equals 0, we know that we have a restriction where x cannot equal negative 5. And now what that allows me to do is cancel both of these out, and we are left with an equivalent expression of 4 over 3. So right away, to go over what restriction is any value of x that makes the denominator turn into 0. So that's why we had set this equal to 0, is to figure out that if x right off the bat was negative 5, this whole denominator would turn into 0, and any number divided by 0 is undefined. Next one, I'm going to factor this right away. My factors of negative 18 that add up to 3, I think would be x plus 6 and x minus 3. And again, a positive times a negative gives me this negative 18. And if I take positive 6 plus negative 3, the greater of those two values gets the plus sign. On the denominator, I have a perfect square binomial. So I have x plus 6 and x minus 6. So let's identify the restrictions first. I know that if I take x plus 6 and set it equal to 0, I would have a restriction at negative 6. And then right here I would have a restriction at positive 6. So we don't want x to be those two things. And then once that's the case, I'm going to take these plus 6's and cross them off. So at the very end, our final answer is x minus 3 over x minus 6. And then lastly, another one we're going to have to factor first. Factors of 40 that add up to 13 would be 8 and 5. And on the denominator, my factors of negative 35 that add up to negative 2, again, one is positive, one is negative, and that's because the 35 is negative. And then the greater of my two factors has to be negative, so that'll be 7 times 5. So negative 7 times positive 5 is negative 35, and negative 7 plus 5 is negative 2. So I'm going to identify what my restrictions are, which x cannot be negative 5, and positive 7, because that would turn my denominator into 0. And at the very end, I'm going to cross off this common factor of x plus 5, and I'm left with x plus 8 over x minus 7. So that was kind of an introduction just to, again, refresh your memory on factoring. If we are multiplying or dividing these expressions, we're able to do a lot of the cancellations. But it's the adding and subtracting when we're going to have to combine as many like terms as we can. So in these ones, we're going to multiply or divide, and then we're going to state restrictions on the variable. So right away, I'm going to state my restrictions on this first one, which is that y cannot be 0, because if y were 0, then these denominators would turn into 0. But what we're actually going to do then is flip the second fraction, because if you are dividing two fractions, you can multiply by the reciprocal of the other. And the reciprocal is, of course, when we flip this. So now what I'm going to do is cross off my common factors of these. I know that 24 divided by 2 is 12. So what I'm actually going to do is divide each of these by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. And then I know the same thing will exist for 7 and 21. 7 divided by 7 is 1. 21 divided by 7 is 3. So what I'm going to do is multiply straight across the top. X to the 4th, y to the 4th, and then straight across the bottom. 2 times 3 gives me 6, and I have an x and then y to the 5th. So I'm going to identify the other restriction that I have. I already know that y cannot be 0, but my other one now is that x cannot be 0. If x were a value of 0, then I would end up with 0 in my denominator. So x and y both cannot be 0. And the last thing I'm going to do is simplify these exponents. I know that I have x to the 4th on top and x to the 1st on the bottom. So if you subtract these, I'm going to end up with x to the 3rd on top And then if you subtract these, 4 minus 5 is negative 1, which means I can leave it on the denominator as positive 1, but then I just have to bring down my 6 as well. So that would be your answer to that first problem. Again, with two variables in there, just make sure you identify the restrictions on both. With this one, I'll identify the restrictions right away again. I'll do it after I factor, actually. That would make it easier. So the first thing I'm going to do is bring down this top, is 5a. I'm going to factor out a 5 here, and I'm going to write a plus 1 times, and then I'm going to factor a 10 out of this, 10 and then a plus 1 as well, over a. So my restrictions, I end up with an a value that cannot be, this one right here means a cannot be 0 if it's by itself, and right here if you set this equal to 0 you would have a cannot be negative 1. So once that's the case, I can start crossing off some factors here. I know that this 10 divided by this 5 is going to end up giving me 2, but I can just write it as 5 divided by 5 is 1, 10 divided by 5 is 2. I know that this a is going to cancel with this a, and I know that this a plus 1 will cancel with this a plus 1. So on my numerator, I really just have 10, and on my denominator, I have a 1. So 10 over 1 is 10. So final answer is 10, but remember, we do have those restrictions right away. So even though everything found a way to cancel out, we still have the two restrictions. Next one. Same thing, we'll factor first. So on the numerator, I'm going to factor out a y, and I'm left with y minus 2. And then I also am going to factor this perfect square binomial as y plus 9 times y minus 9. On the denominator, we'll just bring these down. Okay, so stating restrictions, I know that y cannot be 0 because of this one. And I also know that if I set this equal to 0, y would equal positive 9. So it gives us a restriction at positive 9 as well. So then once we're done with that, we can start simplifying some of our terms by canceling. So I know that this y is going to cancel with this y. I know that the y minus 9 here will cancel with this y minus 9. So on my numerator, I am just left with y minus 2 times y plus 9. And that is your final answer for that problem. There's, again, denominator, you'd really just have an invisible 1, but I'm not even going to write that. So then, last one here is a division problem. So I'm still going to factor first and then find some restrictions. So we'll factor this numerator. Factor as a positive 4 that add up to negative 4 would be x minus 2 times x minus 2. On the denominator, I have x squared minus 9, so it's a perfect square binomial. X plus 3 times x minus 3. Bring down the division. I have another perfect square binomial, so x plus 2, x minus 2. And then lastly, the factors of positive 9 that add up to positive 6 would be plus 3 and plus 3. So what I'm going to do is identify my restrictions right away off this denominator, which x cannot be negative 3 and positive 3. And notice the negative 3 factor repeats again. So now that it's a division problem, I'm going to flip the second fraction just to turn it into a reciprocal. So I'm going to bring this first one down. And keep the same denominator. And now I'm going to change it to multiplication, but again I'm going to flip this fraction. X plus 3 over x plus 2, x minus 2. And now identify the other restriction that we have, which would be at negative 2 and positive 2. And then I can start crossing things off. So I have a minus 2 on the bottom, minus 2 on top. I have a plus 3 here and a plus 3 here. And then notice I cannot do anything else because the signs don't match. So I'm left on the numerator with x minus 2 times x plus 3. And at the denominator, it's kind of like a flip with the signs. I have x minus 3 times x plus 2. And that's as far as you can go. It's not like I can flip-flop my signs or anything. That's just your final answer. Alright, with the sum or the difference, we're going to look for the same common denominator on both of these. So what I want to do is find out what that common denominator is. So in this first example, I'm going to pick the whole number part first, and my whole number part would be a common denominator having 10 in there. And then I'm looking at between the x's and y's, what is the greater exponent of these? So x squared is my greater exponent for x, and then the y squared would be the greater one for y. So I ask, what would this denominator need in order to look like this denominator? And that's what we're going to multiply 6 by on top. So this denominator, in order to look like that, 5 would need to be multiplied by 2. The x squared would be fine, but I would also need one more of these y's. And then I would ask, what would the negative 5 need to be multiplied by in order to look like this bottom? So notice the 10 is already good, the y squared is good, this denominator would need another x. So at the very end of this, I'm just going to multiply out this numerator. I'm left with 6 times 2y, which is 12y, minus 5x over this whole 10x squared y squared. And if I identify the restrictions, it doesn't say to, but if I did, I know that x cannot be 0 and y can also not be 0. On the next one, we'll have to factor first, so I'm going to do that off to the right. I'm going to leave this as 4 over, and then I'm going to factor an x out of this, so I'm going to write it as x times x minus 3 plus 6, and then I'm going to factor a 3 out of this, and I'm also left with x minus 3. So out of all this, we want to build a common denominator. Again, we'll take a whole number part. Looks like there's going to be a single variable involved, and then the x minus 3 factor. So notice I'm going to have a 3, I'm going to have this x, and then I'm also left over with x minus 3. So what we want to do is figure out what each of these denominators would need in order to look like this denominator, and that's what I'm going to multiply the 4 by first. So first thing, in order for this first denominator to look like this denominator, I'm going to need to multiply by 3, and then we'd be good. Bring down the plus 6, and then I want to know what 6 is going to need to be multiplied by for this denominator to look like this denominator, and this would need an x. So I'm going to bring an x over, and then the last thing here is just to multiply this out. So I'm going to rewrite this as 6x plus 12 over 3x times x minus 3. I can still go further than this though. What I'm going to actually do on top is factor out a greatest common factor of this, which is 6. And if I do that, I'm going to be left with x plus 2. And on the denominator, I have 3x times x minus 3. So my last step then is to divide. 6 divided by this 3 means I'm going to have 2 in my numerator times x plus 2 over a quantity of x times x minus 3. Alright, next one. I'm going to be adding, but we'll need to factor again first. So this first one, I'm going to factor on the denominator. I'll keep the numerator the same. Denominator is going to be x plus 3 times x minus 3, or a minus 3, plus, and then leave the second side the same. So looks like my common denominator is going to have the a plus 3 and a minus 3. So the good news is that I won't have to multiply anything by the first one because it already has that common denominator. But the 6 will need to be multiplied by something in order to look like this. So what does this denominator need to look like this one? It's obvious at this point that it's a minus 3. And now what I'm going to basically do is just have to distribute. So on the numerator, I'm left with 4a plus 6a minus 18 all over a plus 3a minus 3. And then my last step is to combine these like terms. I have 10a minus 18 over a plus 3a minus 3. So if I wanted to go further than this, I could factor out a whole number out of this, but notice that there's nothing in the denominator to cancel out with it. So after this point, we are done. So one more of these. Again, what we're going to have to do first is factor. So I'm going to leave this as 3 over, and then factors of negative 10 that add up to positive 3 would be x plus 5 times x minus 2. Bring over the minus sign. Factors of positive 5 that add up to 6 would be x plus 5 and x plus 1. So out of all of this, I'm going to need to build a common denominator. So I'm going to take the x plus 5, which appears in both of these. Notice I'm going to have to bring down an x minus 2 from the left fraction, and from this one on the right side I'm going to have to bring over the x plus 1. So there's something from a little bit of each of these, plus the x minus 5 is in common, and I only have to write it out once. So what does the 3 need in order, or I'm sorry, what does this denominator need in order to look like this denominator? And it would need the x plus 1. So that's what I'm going to multiply 3 by, is the x plus 1. Bring over this negative 1, and we will need to multiply that by something as well. This denominator is going to need an x minus 2 to look like the other denominator. So once that's the case and you're all simplified, I can distribute. So be really careful with signs. So I have 3x plus 3, and then right here negative x, and then you have a negative times a negative, so plus 2. So it's really important that we do leave this x minus 2 in parentheses so that I can distribute a negative sign. And then you'll keep your denominator the same, x plus 5, x minus 2, x plus 1. So then the last step here is just combine your like terms on your numerator. I have a 3x minus x, which is 2x, and then I have the plus 5, and all of that is going to be over the x plus 5, x minus 2 times x plus 1. And then we'll move on to solving. So with these ones, I'm going to teach it using some cross multiplication for the first two, and then for a couple of these what we're going to end up doing is finding a common denominator, and then when you find a common denominator you're actually able to cancel out the denominators. So in this first one we're going to use cross multiplication. So the 4 is going to get multiplied by 5x plus 1, and the 3 times 3x is going to give me 9x. So what I'm going to do is solve this by distributing. I'm going to do 4 times 5x, which is 20x, plus 1 times 4 is 4, equals 9x. And then what I'm going to do is subtract 20x on both sides. So I'm left with 4 equals negative 11x. And then at the very end you're going to divide both sides by negative 11. So x comes out to 4 over negative 11. And it's ugly, but that totally works as an answer. And what you could do is go back and check this in both those fractions, and by substituting in 4 over negative 11 for x, you'd get the same answer. For this next one, same thing. Notice that when there's just one term on each side of the equal sign, we are just going to cross multiply. 1 times x plus 3 is just going to give me x plus 3. And then on the right, 2 times x is 2x. Oh, this is easy, okay. So then what I'm going to basically do is just subtract x on both sides. So then I get 3 equals x. So x is 3. And again, if I wanted to check this, I know that I could leave it as 1 over this x value. So 1 over 3 equals 2 over 3 plus 3, which is 6. And I know that 1/3 is equivalent to 2 over 6. Next one. So notice I have a couple things going on the left side. What you could do first is actually find a common denominator on the left and subtract those two. What I'm going to do is find a common denominator for this entire thing. So I'm going to leave this as 2 over x plus 3 plus 5 over x minus 3. I'm going to set that equal to 6 over x plus 3 times x minus 3. So it's the factored form of that. So as far as a common denominator on all of this stuff, I'm going to end up with x plus 3, x minus 3. So I need to know, what does this denominator need on the left side in order to look like this denominator? And it needs the x minus 3. So what I'm going to do then, first I'm going to write it as x plus 3, x minus 3. I'm going to write this as 2 times the x minus 3 plus, and then I'm going to write the 5 next to an x plus 3. And the reason for that, again, this denominator would need the x plus 3 in order to look like our common denominator. And now I'm going to set that equal to 6 over x plus 3, x minus 3. And I know that because of this left side being the way that it is, I have restrictions on my variable. At the very end of this problem, I know that x cannot be negative 3 or positive 3, otherwise we'd end up with 0. So once your denominators are the same, if you think about it, if you were to cross multiply these, you would end up with a common factor of whatever this denominator is, because it's being multiplied in both of these. So we're actually just going to drop the denominator after a certain point. So what I'm going to do is keep my numerator, and I'm going to distribute, and then we'll just solve from there. So 2 times x is 2x, 2 times negative 3 is negative 6, and then plus 5x plus 15. And I'm going to set that equal to positive 6. So at the very end, let's just simplify. This is going to give me 7x plus 9 equals 6. Because of the negative 6 plus 15, that's where I'm getting 9. I'm going to subtract 9 on both sides. So I get 7x equals negative 3. So it's an ugly answer, but it totally works. X is going to be negative 3 over 7. And again, we could take that, substitute it back in, and you would get that same answer again. Last problem, this one's going to work out pretty similar as well. I'm going to bring down my first fraction as 4 over x minus 3. I'm going to bring this down as 2 over x plus 1. And then I will need to factor. My factors of negative 3 that add up to negative 2 are going to be x minus 3 times x plus 1. So notice that this third one contains the denominators from the first two fractions. So let's do that same thing where we're going to look for what does this denominator need to look like a giant common denominator. The 4 is going to need an x plus 1. This 2 is going to need the x minus 3. And I can already see the 16 with that denominator already has everything that the other two have. So that equation would turn into this equation. Because again, once you find that common denominator, you can just get rid of it. So as far as the restrictions would have gone, again, I know that I'm not going to end up getting positive 3 or negative 1 as one of my answers. So I'm going to distribute. So I get 4x plus 4 equals 2x minus 6 plus 16. So then I'm going to bring this down as 4x plus 4 equals 2x plus 10. And then we'll just solve this. I'm going to bring over the 2x on the other side. So by subtracting, and I'm going to bring the 4 over here. So 10 minus 4 is going to give me 6. And then I know at the very end when I divide, I'm going to end up with 3. But the problem is I have a restriction at positive 3. So even though positive 3 comes out to my answer, when you take positive 3 and you substitute it in here, 3 minus 3 is going to give me 0. And 4 divided by 0 is undefined. So there is actually no solution to this problem. So even though I end up with positive 3 at the very end, that's what we would call an extraneous solution. We knew that we had a restriction on that variable, so we actually have no solution.